Hey everyone. So in this video I like to talk about angles and radians. So one common quantity we like to measure in geometry and mathematics, and one that we'll refer to quite frequently in this class, is this idea of an angle, which is typically used to measure rotation. And so before I define what an angle is, let me define a few other relevant terms. So lines, this is something you've probably seen before and something you've dealt with in algebra. Right? It's a sort of one-dimensional object that's kind of like a straight object that goes off in both directions. And the point I want to emphasize right now is that it sort of goes off in both directions indefinitely. Now, a line segment is kind of like a sort of the opposite, right? It's kind of like the same thing, but instead of going off in both directions indefinitely, it kind of has endpoints at both ends. And then an array is this object that's in between. It's, one side ends, whereas one side goes off indefinitely. And so an angle, it consists of two rays joined at a common point. Usually we call this common point the vertex, a vertex. Right, so here maybe just to draw a picture is that we can kind of have one ray going off in this direction, one ray going off in another direction, and there's this common point. This is the point that we call the vertex. Okay, and so the measure of an angle is this sort of rotational measurement that it would go from one ray to another. And usually we call the first ray, the ray we kind of imagine starting with, we say that this is the initial side. And sort of in this picture, this bottom ray would be kind of what we think of as the initial side. And the other ray, the ray where we kind of imagine ending up at the other side of our angle, we think of as, or refer to as, the terminal side. Right, so here, the second ray. If I'm imagining the rotation I kind of have depicted in blue, the second ray is this terminal side. Some other ideas that we have when it comes to angles and measuring them is that we like to think of counterclockwise rotation. It's thought of as sort of a positive angle measurement, whereas clockwise we'll think of as negative rotation. So maybe a picture in here is that kind of like our original picture on the right. Right, so this sort of rotation going counterclockwise, we're going to consider as sort of a positive angle measurement. Whereas if we were to go in the other direction, this would be considered, this is clockwise, we would think of this as a negative angle measurement. Some other things that we'll commonly see when it comes to angles is, we'll need to refer to angles quite frequently, and the convention is to use the Greek letter theta. Right, so the convention for referring to angles I think there's two R's here. One kind of word I'm bad at spelling. Okay, so the convention for referring to angles is to use the Greek letter theta. Right, so this is how it's written. Right, so I might call this angle up here, I might call this angle theta to refer to it. So still some more terminology to go over. An angle is in standard position if its vertex is at the origin and its initial side is positioned on the positive horizontal axis. So kind of imagine something like this is not in standard position. Whereas kind of if you imagine your angle positioned kind of on a coordinate plane, here maybe I'll draw a coordinate plane. There doesn't have to be a coordinate plane pictured out, but you can kind of imagine one there that where the vertex is sort of at the origin and the initial side is placed along the horizontal axis, and the terminal side can kind of be wherever. This is an example of an angle in standard position. Just to have some consistency about how we refer to angles. So here, this is not standard, it's kind of tilted off. So, when we talk about angles in this class, we'll typically be thinking about angles in standard position. And all the previous examples that I drew, I kind of meant to draw them sort of in standard position. Okay, so let's go ahead and go over a few examples of important angles I'd like you to have remembered and readily available in your mind. So, we've already talked about one example of one of these angles. So this left example is a 90-degree angle, right? So an angle that kind of depicts the corner of a square, right? So if I kind of imagine, the initial side and the terminal side as a rotation, the terminal side is sort of 1/4 of the way all the way around, right? So this is a 90-degree angle. Kind of very similar angles, this 180-degree angle, where the terminal side ends up on the opposite end of this initial side, right? So here, 180 degrees. And then 360 degrees is if we were to take the initial side and we were to swing it all the way around, rotate it all the way around, and have the terminal side sort of end up in the same position as where we started. And so one thing I want to point out is that this last example, it also kind of looks like 0 degrees, right? Maybe I should say that it looks like 0 degrees. I kind of just mentioned that this is 360 degrees, but right, the initial side and the terminal side, they ended up in the same position in this case. One definition I want to bring up to refer to that is this idea of coterminal angles. So if we have two different angles, for example, 360 degrees and 0 degrees, we call these coterminal angles. Two different angles are coterminal. Right, their terminal sides kind of agree with each other if their terminal sides have the same positions. Right, so 360 degrees and 0 degrees are examples of coterminal angles because they kind of look like they're in the same position. Maybe just to give you another few examples of coterminal angles. So 90 degrees, negative 270 degrees, and 450 degrees. These are all examples of coterminal angles. Right, so here maybe let's talk about these. So we already have 90 degrees depicted. Let's take a look at what negative 270 degrees looks like. So if we kind of have an initial side here, negative 270 degrees, that's telling me rotate in the clockwise direction, right? Negative angles depict clockwise rotation. And so we know 180 degrees would be half rotation, right? So all the way around, this would be 180 degrees, negative 180 degrees that is. And then, well, negative 270 is negative 90 tacked on to negative 180. So we have another quarter turn. Right, so at the end of the day, our terminal side ends up here. Right, so this angle looks a lot like our 90-degree angle, and so we call these two angles coterminal. And then just to really illustrate that 450 degrees is also coterminal. Right, so let's kind of work through this example, right? If I have my initial side here, well, 450, right, it's more than 360. So, right, 360 degrees is going to rotate me all the way around this circle. But then there's still 90 left, right? 450 is 90 more than 360, and so I'm still going to go another 90 degrees past that of rotation. And here's going to be my terminal side. Right, so again, I get this, what looks like to be a 90-degree angle, but we're going to call it 450 degrees. I really want to think of these coterminal angles as different angles. They just make your terminal side end up in the same position in these different angles. Okay, so here let's go ahead and sketch a few more examples of important angles. So these examples up here, these are all ones that you ought to be able to pretty quickly pull or cook up or think of. And here are a few more that we're going to constantly talk about throughout this class. So here, maybe take a moment to pause the video and see if you can sort of draw or depict these three different angles. So 60 degrees, 30 degrees, and 45 degrees. Okay, so 60 degrees, what does that look like? Well, I know if I have my initial side here, I know if I were to go all the way across, right, I would have 180 degrees, right? And 60 degrees is a third of 180. So here, maybe I'll just kind of put a little dotted line, dotted ray to show 180 degrees. And 60 degrees, it's 1/3, right? So it should, if I kind of split this up into thirds, right, so this here represents 60 degrees. And maybe just to extend this idea a little bit, we already have all of the information here. If we were to push this, this second ray that kind of goes in between, right, that's 2/3 of 180, and that's 120 degrees. Right, so here is 60 degrees. Again, it's 1/3 of 180. 120 is twice that, so 2/3 of 180, and you can kind of see that what that angle is there. And that's another angle we'll look back at quite a bit. Now 30 degrees, well, it's half of 60 degrees, right? So if I kind of imagine a 60-degree angle here, that's 60 degrees. Actually, maybe let me draw it in sort of similar dotted line fashion. So if that's 60 degrees, 30 degrees would be half of that. Right, so here this is supposed to be 30 degrees. And we can kind of imagine, kind of in the same fashion, that it would take 6 sets of these to go halfway, or to go all the way across to 180 degrees. And I can kind of imagine here that, if I were to tack on another 30 degrees, I would get my 90-degree angle. Another 30 degrees, I would get my 100-degree angle, or 120-degree angle. Another 30 degrees, I get 150, and then this last one would be 180. Another 30 degrees would bring me all the way to 180. It's just a rough sketch, but hopefully this gives you some sense of just the bigger picture with these angles here. And maybe let's do one more, right? So 45 degrees. This is half of 90, so I can kind of imagine my right angle. And then, right, half of that rotation would give me my 45-degree angle. So, it might look something like this. Actually, I could probably do it a little lower. Right, so this is my 45-degree angle. Okay, so we'll typically be thinking about angles that are multiples of 30, multiples of 45, and multiples of 60 are also multiples of 30, but I want to kind of also think of those sort of in their own category as well. These will all be important kinds of angles that we'll talk about all the time. And so maybe just to continue in this fashion, let's sketch angles of a few more different kinds. Let's do 300 degrees, 120 degrees, and negative 225 degrees. So pause the video and sketch these different examples out if you can. And maybe if you're up for it, take a moment to also think about what are some examples of coterminal angles to this last angle here. What are other angles that end up in the same position as negative 225 degrees? Okay, so for this first example here, for 300 degrees, we can kind of, there's a few different ways to think about this, and I think all of these have their benefit. We've kind of been doing the same thing as sort of break up the angle into bite-sized chunks, right? Into chunks that I'm very familiar with. I know that 300 degrees, well, that's going to be more than 180, right? So it's going to be more than this rotation all the way across. And then how much more? Well, it's still got another, how much to go? 120, right? So if this is 180 degrees, right, I still have another 120 to go. So I know I'm more than 90 degrees more, right? So this would be 180 degrees. This would be another 90, or in other words, this would bring me to 270 degrees. And so I would need another 30 degrees on top of that. So here, maybe a nice sketch of this angle. This would be the full 300 degrees. Maybe I'll do this in a full, right, so an extra small 30 degrees on top of the 260. And it might also help you recognize this angle by looking at it and saying, well, this is actually 60 degrees shy of the full 360-degree rotation. And this kind of looks like 60 degrees here, right? So, I don't want to, I kind of hesitate to write this because I'm drawing in the clockwise direction. This is kind of like negative 60 degrees. So, it's not exactly the same angle, but it might be helpful to kind of think backwards a little bit in terms of the full rotation being 360 degrees, and that this angle should be sort of 60 degrees, just less. Okay, and then 120 degrees, we already sort of drew this picture out, but it doesn't hurt to do it again, right? So here, kind of in the same vein, we know that 120 degrees is there's two different ways to think about it. We can kind of think of it as 2/3 of 180 like we did in the past, or two sets of 60 degrees. Another way we can kind of think of it as 90, right, or right angle, but then tacked on with another 30 degrees. So, maybe like so. And so here, this might be my 120 degrees. Right, and it feels like it's roughly 2/3 of our 180 degrees. So hopefully that feels about right. Okay, and this last one, right, it's another example of a negative angle. So we're going to have some clockwise rotation. And so here, negative 225 degrees, right? So again, we play the same game where, I know that I'm going around 180 degrees at the very least. This is negative 180 degrees. And then, well, how much more do I need to go to get to my negative 225? Well, negative 225 is negative 45 more than negative 180. So I would go halfway across another 90-degree angle. Right? So it looks something like this. Right? Maybe just to sort of add the structure in, just to sort of see where this idea is coming from. Right? So here's that 180, here's that 90, and maybe halfway in between. We can probably do a little better than that. Maybe a little lower. Is this negative 225 degrees. All right, so that's this rotation here. It's negative 180 tacked on with another negative 45. So this is negative 225 degrees. And so, what are some coterminal angles? What are some other angles that would bring us to the same position? Well, right, we can kind of see that if we were to go 90 degrees and then an extra 45, we would end up at the same position, right? So this is coterminal with well, 90 plus 45, that would bring me to 135 degrees. Right, it kind of makes sense because if I were to add on another 45 that we know, this angle is 45, degrees in rotation. That would bring us to 180 degrees all the way to the other side like we would expect. So, right, 135 is an example of a coterminal angle to negative 225. Okay, so hopefully that gives you some idea of how to work with degrees, how to imagine degrees, and that it's typically a good idea to kind of break it up into pieces that you recognize or that you're comfortable with. I kind of want to take this to sort of a different idea now. I want to talk about this idea of radians. So although degrees are what you're probably familiar with, and they're commonly used outside of the sciences to measure angles, many important results in mathematics depend on measuring angles in not degrees, but in what we call radians. And so it's kind of built up on this idea that for any circle, of maybe we'll call it of radius r, how do we compute the circumference of that circle? Well, the circumference of any circle is 2 pi times the radius. If I draw a circle, no matter what the radius is, the circumference, right, this is just the word for the perimeter of a circle, or the boundary, measurement of the boundary of the circle. Right, whatever the radius is, the circumference is 2 pi times that radius. 2 pi r. And so this idea of radians, and it's one that we're going to be constantly using in this class as well, and one that I really encourage you, you're going to need to get more comfortable with and use over degrees. So radians it's a measure of how far along the circumference you are, the circumference of the circle you are, in terms of the radius of the circle. So radians measure how far along the circumference of the circle you are in terms of the radius of the circle. Right, and so, maybe one example to really illustrate what I mean by that is that, if 2 pi r gives me the circumference, tells me that I'm going all the way around this circle, I can kind of think of 2 pi radians as a full rotation of my circle. So 2 pi r, right, this corresponds to the full circumference so radians is just telling me, how many copies of my radius I am going around my circle. And so, right, if my circumference is computed by 2 pi copies of r, 2 pi times r, 2 pi sets of r, then going all the way around my circle is what I'm saying is 2 pi radians. Right, so here, just to include a quick picture, If we were to go all the way around the circle, we would be going 2 pi radians around the circle. And I can kind of think of this like going around 360 degrees, right? 2 pi radians is kind of analogous to going to rotating 360 degrees. And in a similar vein, pi r, if 2 pi times our radius gives us the full circumference of the circle, then we know that pi times r, half of that, is half the circumference of any circle. Right, this is saying that 3.1415, right, a little bit more than 3 sets of our radius will bring us halfway across our circle. It's the same measurement of half of our circle. And so, to refer to this in radians, we're kind of like saying that pi radians is sort of halfway around the circle. I guess I didn't finish the idea in the previous example. 2 pi radians is, how should I say this? A full way around the circle. Right, so pi radians commonly we'll write radians using this statement rad. So pi radians, this is kind of like saying we're going across 180 degrees. It's kind of analogous to 180 degrees. And so hopefully from these two examples you can kind of get a sense to see how radians measure angles, right? They measure angles in the same way that degrees do. And so here we can kind of think of our common angles in terms of here, let me rephrase. So in a lot of the previous examples, when we tried to determine where our common angles look like 60 degrees, 30 degrees, 90 degrees, 45 degrees, we sort of constantly referred them or compare them to 180 degrees. And so when we want to think about our common angles in terms of radians, we'll kind of want to do the same thing. We'll want to sort of compare them to pi radians. Right, so if pi radians is going to get me halfway across the circle, what do you think $90 degrees will look like in radians? Right, so pause the video, take a moment to think about this. What should 90 degrees look like in radians? So, if we know that 180 degrees corresponds to pi radians, well then half of 180 degrees is 90, so half of pi radians should correspond to 90 degrees. Right, so here, let me draw this picture. If I have this circle here, right, we know 180 degrees would be halfway around the circle, and then this would correspond to pi radians. Well, 90 degrees would be half of that. And so pi over 2 radians would correspond to 90 degrees. And this kind of makes sense because, 2 pi r gives me my circumference of a circle. And so dividing that by 4, right, 2 pi r, or 2 pi r divided by 4 gives me, pi over 2 times r. Pi over 2 sets of my radius gives me a quarter of the circle. So pi over 2 radians corresponds to this 90-degree or quarter rotation. Okay, so let's try and do something similar here. I've got 3 examples of angles that I'd like to think of as angles in radians. And I want to figure out what the corresponding angles would be in degrees. So if you're ready, or if you're feeling comfortable enough with this idea, let me ask you to pause the video, try this out, see if you can figure out what angles these are representing in degrees. So, again, I feel like our big idea here is that pi radians corresponds to 180 degrees, and really we can think of computing these radians, or recognizing what these angles are. These angles that are in radians. We can recognize what they are in degrees by sort of thinking of, what portion of 180 are they. Right, so this pi over 3 is, if pi radians corresponds to 180 degrees, then dividing that into thirds, right here, maybe let me draw a picture. That should give me a third of 180 degrees, right? So here, this is 180 degrees. It's pi radians. We're asking for pi over 3, right? So we want thirds of this 180 degrees. This is pi over 3 radians. And so a third of 180 degrees, well, that's 60 degrees. These two represent the same idea of an angle measurement. What about pi over 4? So again, you're right, pi is 180 degrees. Pi corresponds to 180 degrees. We already saw earlier that pi over 2 corresponds to 90 degrees. And so, pi over 4 is just a half of pi over 2. Right, so it's to cut this into another half, or you can think of taking pi radians and cutting it into fourths. Well, 1/4 of 180 degrees, that's 45 degrees. And so pi over 4 radians, this corresponds to 45 degrees. And the last example is pi over 6. And we've kind of already talked about, splitting up 180 degrees into thirds and into 6. But we can do this again here. So here we've got 180 degrees. And we know that, splitting it up into thirds gives us, pi over 3 radians and 60 degrees. Right, this is 2 sets of pi over 3, or it corresponds to 120 degrees. And this is pi, this is 180 degrees. So that's cutting this 180 degrees, this pi radians, into thirds. If we were to cut it into 6, we'd really just be taking each one of these and cutting them, splitting them in halves, a little bit further. And this would give us our 30-degree angle that corresponds to, 1/6 of 180. And so pi over 6, this corresponds to 30 degrees. Okay, and so this is really one of the main things I want you to take away from this video, is that, we're going to be dealing with angles in radians all the time in this class. And really the ones we're going to be dealing with and working with are going to be based on these 60-degree angles, these 30-degree angles, and these 45-degree angles. And so what you really want to have and feel comfortable with is the fact that pi over 3 radians, that corresponds to 60 degrees. It corresponds to this idea of taking 180 degrees, or pi radians, and splitting it up into 3. Right, so 60 degrees. And then we can apply that same idea for pi over 4 to get 45 degrees. Really, we want to have feel real comfortable with this idea that pi over 4 radians is 45 degrees. And then lastly, pi over 6 radians, or in other words, taking 180 degrees and splitting it up by 6, well, that gives me 30 degrees. Pi over 6 is 30 degrees. So these are the 3 of the main radians I want you to have really solid understanding of. And then so the other ones we've already talked about quite a bit, but here we saw them as 2 pi radians is the full rotation. It corresponds to 360 degrees. Pi radians is 180 degrees. We've been talking about that quite a bit. And then pi over 2 radians, half of pi, that corresponds to half of 180. It corresponds to 90 degrees. So these are all the examples of radians I really want you to know.